Hi everyone. Today topic is time shifting or translation. Time shifting or translation. Time shifting is also called translation. Time shifting maps the input signal is X and the output signal is Y. The input signal is X and output signal is Y. And the equation of output signal y of t is equals to x of t minus b, where y is the function, t is the time, and b is the real number, Such a transmission shifts the signal will be shifted from left to right, or right to left, or bottom to top, or top to bottom along the time axis. If b greater than 0, the function y is shifted to right by mod b relative x delete. If real number b is 0, less than 0, the wave is shifted to the left. If b greater than 0, the wave is shifted from right side, and wave is b less than 0, the wave is shifted from left side. Here these are the different times shiftings. For example, x of t. Here there is no positives and negative numbers are not applying. That's why it is equally splitted or equally transmitted given wave +1 -1 +1 -1. And second diagram is x of t minus 1. Here in this, the wave is shifted to the right side, and x of t plus 1, the wave is shifted from left side. So the overall shifting conditions will be depends on b real number. If b greater than 0, or if b greater than 0, at the situation the wave is shifted from right and shifted from left. This is the one of the topic, time reversal or reflection. Time reversal is also known as reflection. That means it is like a mirror. Here in this mirror, for example, the wave is displaced from the opposite direction. In the same manner, we are also seeing the below diagrams. If x of t wave is like, and x of minus t wave is in the reverse of x of t. That means time intervals when we are applying, the wave is the wave is splitted reverse operation. That means when we are applying time in reversal from any signal, the signal will be appears like opposite of original signal. So geometrically, the output signal of y is reflection of the input signal x about the vertical line t equal to 0. The function y of t equal to y of minus t. Simply we know y is the positive way and x of minus t is the negative way. That means by we are applying time intervals, the signal will be activate like reverse operation. Next topic is time compression or expansion or dilation. Time expression or expansion is also called dilation. The time and compression or expansion maps the input signal x to the output signal y is given by y of t equal to x of at, where a is the strictly positive real number, where a is the strictly positive real number. Such a transmission is associated with a compression expression along the time axis. Along the time axis. In this also we are seeing two conditions. If a greater than 1, if a less than 1. If a greater than 1, the function of y is compressed along the horizontal axis by a factor of a relative to x. If a less than 1, the y function of y is expanded. If a greater than y 1, the data will be compressed or decreased. If greater than a less than 1, the data will be expanded along the horizontal axis by a factor of 1 by a relative to the x. These are the compression techniques of time intervals. These are the compression techniques of time intervals. Here we are seeing x of t, x of 2t, x of 2 by t, x of t, x of 2t and x of t by 2. That means when we are increasing or decreasing data rate or signal transmission rate will be depends on the time intervals. These are the three different types of signals, and those have contains several time intervals. These are the expanding and compression process, the time expression or expansion examples. Next one of the major important topic, time scaling. Time scaling. Time scaling maps the input signal x to the output signal y. That means the function of y of t equals to x of at, where a is a non-zero real number. So in the terms of time scaling, a is a non-zero real number. In the terms of time expansion, a is a strictly positive real number. We are observing the difference of a in the process of compression and expansion. A is known as strictly positive real number. In the time scaling, a is a non-zero real number. Such a transmission is associated with dilation or expansion. The compression or expansion along the time reversal. In this also we are seeing same conditions of time expansion and time scaling. If a mod a greater than 1, mod a less than 1, the signal will be expanded and compressed and then expanded. Compressed and expanded. These are the time scaling examples. These are the time scaling examples. In this also we are seeing different variations of the signals x of t. Some time intervals will be increased. x2 of t, x2 of t only minus 0.5. The signal will be lies in the process of x of t. The signal is lies between plus 1 to minus 1. In the process of x of minus 2t, the signal is lies between 0.5 to minus 0.5. If the x value x of t by 2, the signal is lies between 2 to minus 2. If the signal is x of minus t, the signal is plus 1 to minus 1 and phase will be reversed. So by using time shifting and time scaling and time compression and time expansion, the signal will be changes in different forms. The signal will be changes from different forms. It is a time scaling, it is a time compression and expansion, and it is a time reversal and that means reversal operation, and it is a time shifting. That means the overall concept of time shifting, time scaling, time expansion, time compression, or time expansion and compression and time reversal, these are all used to change the behavior of the signals with respect to time and frequency. So this is the concept of time scaling, time shifting, time reversal, and time expansion and compression. Thank you.